Hello there, this is John Everest, and I think this is the fourth discussion moving through the daylight phase methods. Previously, I sort of talked about how we divide the sky. I talked about the methodology of a two-phase method, and then I moved on to the three-phase method, and I just simply touched on its advantages and limitations. You start to lose a bit of the sharpness of the rendering. Sort of blinds become average window contributions happen. It's the same light energy entering the space, but it is averaged. So if you're you just need to understand that the data you're trying to get from your calculation. If it's a if it's a marketing image, well, that's not fit for purpose, is it? Well, I would imagine. But if you're simply trying to understand the quantity of light entering the space, particularly if you're at concept stage, or a sort of a developed design stage, you are going to save yourself a lot of time, and perhaps reduce project bottlenecks by getting your calculations out quicker. So that was the two-phase, and I hope you understand when you might want to use it and when not, and with the three-phase. And now let's discuss the four-phase. It's often referred to as the F metric. The four-phase is actually, as I said, this is a nice document, and let me just I just want to make sure I give due credit. I did rate it at the beginning, but this is it's a lovely document. I like it, by Sareth. Daylighting simulations with radiance. Yeah, I didn't write this. I'm just sort of it's, as I've said before, it's very accessible, but if you're not familiar with the methods, I doubt you'd make your way through. So the four phase. So the three phase, we can go from the sky to the window to the interior, and that has advantages, and we can control the accuracy of the calc individually, the transfer of light through the glass, its distribution on the interior and its distribution on the exterior. We can have different accuracies, different light bounces, and we can change one without having to recalculate the other. So why on earth would we ever need more? Well, imagine this scenario where we have a fenestration on the window that's fenestration, like a detailing, and it's not unusual, is it, where you're going to need some kind of solar control on your window. So now you're developing your design, and it's great that obviously our external environment doesn't change. The buildings don't move or change or anything like that. The only thing that's changing is inside here, or actually all our window. If our window surfaces changed inside, chances are we would have to recalculate that as well. But that's all great. But now you say, okay, well now I want to know what's the value of actually putting a light shelf above my window. So I haven't, in one side, well, nothing's changed of sorts in that, the trees are still there, the topology is still the same, the buildings are still the same. However, because you just put that there, you change the external environment. So now you do have to recalculate all that. You don't have to calculate the interior because the change happened on the exterior, but you now have to recalc all this. And there is another weakness, because let's say you're doing a lightweight coarse calc just to collect the energy. It's more, from the outside you're doing like 2 ambient bounces, and you've got your sort of ambient accuracy set, reasonably low, because it's more about the most important part is understanding obstructions, but there will be reflected light as well off the ground, off surrounding buildings. But because of the size, you want to keep that calc lightweight. Well, let's imagine that fenestration looks like this. Okay, it has that level of detailing. We're back to the dilemma that we need an accurate calc to move that through. It's not going to be good enough to say, well, we have an accuracy of like a meter. And so, well, let's say that's only half a meter anyway. That's not going to be very good. So we could pick up the shadow patterns, but not the inter-reflected light. So the fourth phase actually adds another phase, and it is an isolated calculation where we can control the light occurring in this area here. And Yeah. So I think that if now you've got your head around the three-phase method and how it works, I think you could understand how the four-phase method works. Providing your fenestration lives within the sort of defining area, the defining area, you will only have to recalculate this. Then you do not have to recalculate your external environment or your internal environment or even your glazing. You only have to rerun a calculation for that and then bring them all together. Sky, so it's the start, the sky, the daylight phase, I guess it's called F for the fenestration phase or something like that, the transmission phase to the view phase. Okay, and then the four phase has like different stages, and you could just simply do the sort of like levels. I think they number them like F1 to even more, but yeah, very simply, you could just put this panel. It's like a window on front, isn't it? And you go from the sky. You load your light energy onto this panel, and then you look at the transfer of light from this panel across to here, and it will be the average as well. So it will be sort of the average of the light coming into the top of the panel and to the low. So it's a quicker calc. It generates less data, and I keep bringing that up. It generates less data because, my word, it's I'd recommend the way to do these things is like, you use like like the Grasshopper plugin or the Honeybee plugin for Grasshopper or something like that. But if you're doing it manually from the command line, it is kicking up huge quantities of data. Although ironically, after saying that, you can't do a four-phase with Honeybee. Yes, maybe they're working on it. But anyway, there are variants of the four-phase where here the risk is light can leak in from the side. Yeah, so if you're in a scenario where you're never expecting light to come in from the side, then that is appropriate and you will save some time. I would imagine in most cases light would sneak in from the side, so then you have to put in like extra. Just think of these as windows, like in the three-phase method. Yeah, so you've got a window on here to collect, to transfer, and go into the inside, and now you have extra windows on the sides and the top and the bottom. Yeah, that's nicely shown, isn't it? And then you can go even further and have extra windows. Because you clearly want to divide between. To be honest, I'm not sure the value of that. You would clearly want to like sort of divide and say, well, this is the light coming in at the top above the light shelf. This is the light coming in below. Yeah, so any light up here needs to transfer through this penetration. This detailing. Any light below gets straight in, and I think is there even another? No, that is as far as it goes. But again, look at how much more data that's made. That's like 1, 2, 3, 4, 5, 6, 7. Yes, another 7. Technically, they're all phases. So you sort of add the phases together internally, and then just transmit it to the window. But again, it's a huge quantity of data to work with. I've done it technically, but commercially I've never applied it to a project because I just worry. There's a lot that can go wrong, and then again, do you remember how I said how like then you start to look at like accuracy in that there's like I say there's you start to get the blurring, and you start to lose the detail. Well, imagine there's another phase on top of that. So here's the reduction from a 2-phase to a 3-phase. So a 4-phase will be this phenomenon will be even more pronounced on the 4-phase. So you need to be aware of that, and that's another reason I haven't applied it commercially, because I've not had the time or the inclination, to be honest, to check what does all that mean. But the advantage is you can start exploring all these different options without having to recalculate your exterior or interior phases. So I think it's a case of you need to. For me, I would await the right project. I would not be doing this for self-indulgence or self-torture. I would be waiting for a project that says I need to do it, and for the kind of projects I get, it hasn't come up yet. Okay. I don't think there's anything else I want to tell you about the 4-phase. So the next one is moving on to the 2-phase DDS, the 5-phase and the 6-phase, and basically the 5-phase is basically an extension of the 3-phase, and the 6-phase is an extension of the 4-phase. And the 2-phase DDS, I always forget what DDS stands for, but the 2-phase DDS is an extension of the 2-phase, and I'm hoping I can actually I will be able to just cover them all in one more tutorial, then we're done. So thank you for listening. I'll cut it here, and we'll wrap this up just going through these final phases. I will see you on the next one.